So in number 11, we have a 5 times 10 to the 4th kilogram space probe is traveling at a certain speed through deep space. The retro rockets, now retro rockets are fired in the direction the object moves in order to slow it down. Okay, so the retro rockets are fired along the line of motion to reduce the probe speed. The retro rockets generate a force, so that we know the force and we know the distance, over a distance of 2,500 kilometers. What's the final speed of the probe? Well, we're out in space. So we're out in space, there's no potential energy, gravitational, it's just K. So my equation is going to be KO plus UO plus W equals KF plus UF, and I can cancel out UO and UF. And since all of the numbers up here are given in terms of mass and velocities and forces and distances, I'm going to take each of my generic variables for energy and I'm going to replace them. So this is going to be 1/2 mvo squared. Now I know that the work is a negative work. So I know that now, like, I could put it as a plus, but then I need to make sure that I write that as negative 4 times 10 to the 5th. But I'm just going to put it in here so I don't have to worry about signs. I'm going to put it in as negative right away. And that way all my numbers that I do substitute in are going to be positive numbers. So 1/2 mvo squared minus fd equals 1/2 mvf squared. And the question is, what's the final speed? So I just have to do my algebra, rearrange it, plug in the numbers. So the equation contains fractions, so we multiply by the least common denominator. So I get mvo squared minus 2fd equals mvf squared. To solve for vf, I'm just going to move the m down here and take the square root. So when I'm done with that, I'm going to have vf is going to equal mvo squared minus 2fd divided by m. So I wasn't able to cancel m out in this problem because the work was there and there's no m in that term. So when in the absence of work, you can usually always cancel out the m's because we have m in kinetic and potential energy equations. We just don't, kinetic and potential energy equations. We don't have it in work. So that would equal vf squared. So we want the square root of that. And so plugging in the numbers, we're going to get m vo squared minus 2fd all divided by m. So the m is 5 times 10 to the 4th kilograms. So I'm going to put that right in here. 5.0 times 10 to the 4th kilograms there and there. The original velocity is 1.1 times 10 to the 4th meters per second. The force is 4.0 times 10 to the 5th newtons. And again, that would be a negative force, but I've already taken care of the direction in my energy equation. And the d, 2,500 kilometers, that needs to be in what unit? Can't leave it in kilometers, right? I have to have that in what? Meters. So 2,500 kilometers is the same thing as 2,500,000 meters because there's 1,000 meters in a kilometer. So that means that number is going to be 2.5. Instead of times 10 to the 3 for kilometers, it's going to be times 10 to the 6th for meters. And if you solve that, that's going to give you the answer for this. And that should have worked out to be 9.0 to get at least 2 significant digits times 10 to the 3rd meters per second. So that is a smaller number than the original velocity. That would be like, that's like 11,000 meters per second down to 9,000 meters per second.